Hi everyone, welcome to STEM class. In the last lesson, we built a strong truss bridge. In this lesson, we will use 3D printing to make an interlocking puzzle toy. In daily life, we can see many ways to connect different things. For example, screws in toys can hold parts firmly together. Nuts and bolts can make furniture strong and durable. Different kinds of glue can stick objects tightly together. But what if we do not use screws or glue? Can parts still lock together firmly? Before metal fasteners and adhesives became common, how did people connect pieces of wood in a strong and stable way? People in the past came up with a very clever method. It is called a mortise-and-tenon structure. The part that sticks out is called a tenon. The matching slot is called a mortise. When the tenon fits into the mortise, the two parts can hold each other by their shapes and lock tightly together. A mortise-and-tenon structure has another amazing feature. It does not glue the wood pieces together permanently. Instead, it lets the wood pieces interlock by shape. This makes the connection strong. If one part is damaged later, people can take it out, repair it, and put it back again. Many ancient buildings over 1,000 years old are sturdy and long-lasting, thanks to mortise-and-tenon structures. Today, we will use 3D printing to make an interesting structure toy, a Luban lock, also known as a burr puzzle. The Luban lock is said to be connected to the ancient carpenter Luban, and its structure comes from traditional mortise-and-tenon ideas. Are you ready? Let's start today's structure exploration and make a sturdy Luban lock together. First, find the models we need for this lesson and print the parts in order. For this lesson, we need to print one set of Luban lock pieces. You can choose colors you like and print the parts in different color groups. Look, the 3D printer is working now. Printing takes some time, so please wait patiently. We can take a short break. Great! The parts are ready. Place the separated Luban lock pieces on the table and take a close look. Can you find the parts that stick out? These parts are like tenons. They stick out and slide into other parts. Now look for the recessed parts. These parts are like mortises. They hold another part. You can pause the video here and try the assembly challenge by yourself. If you cannot put it together yet, don't worry. Next, I will show you how to assemble it. Place the pieces one by one in the order shown on the screen. First, take the first and second pieces. Find the slots in the middle and slide them together. Next, add the third piece. Continue in order and put the remaining pieces in one by one. Congratulations! The assembly is complete. Now the Luban lock has become a sturdy little block. Pick it up and turn it around. It does not come apart right away. This is what makes the Luban lock so interesting. It is not held together by glue, and it is not tightened with screws. Instead, the shapes of the pieces interlock with each other and limit how each part can move. In the end, the whole structure locks together. In today's lesson, we learned about the mortise-and-tenon structure. We also used a 3D printed Luban lock to observe how parts interlock and lock together. In ancient times, people used this clever structure to make furniture and build wooden buildings with mortise-and-tenon structure. Today, we can still see similar structures in many places. So structure design is not only about materials. It also depends on shape, direction, and order. Tiny parts hold great engineering wisdom. 3D printing, your great learning partner. Keep exploring, and see you next class.